Hi, how you doing? And welcome back to youtube.com/Wi-Fi Sheep with me, Tom. In today's video, we're going to take a look at a fantastic 32-bit ARM-based learning and development board brought to us by Taiwanese microcontroller manufacturer Nuvoton. Now, Nuvoton is just one of the many tech-based suppliers on the rather brilliant TechDesign.com marketplace. TechDesign's unique marketplace allows a direct source and link between manufacturers and people like us in the tech community. So whether you're sourcing a small quantity of components for testing or a larger purchase for mass production, all orders are processed and shipped directly by the manufacturers listed on TechDesign.com. For example, you can directly place an order on TechDesign.com and the product, in this case a Nuvoton microcontroller dev board, will be shipped directly by Nuvoton to you worldwide. It really is that simple, and there's so much to explore on TechDesign.com with many products I've never seen anywhere else. So trust me, do go and take a look, it really is quite something. And from Nuvoton via TechDesign.com, I have a rather fantastic ARM Cortex-4 32-bit learning and development board called the NULB M451. Links, by the way, are in the description to the video. So let's take a closer look and get this dev board up and running. So here is the NULB M451. And it uses the Numicro family M451 series learning board. And this is what the particular package looks like. And I have to say it is very, very well packaged. It's a good solid plastic case. On the back here, it talks about what this is for. So this basically is a very general learning board for the Numicro architecture, which we'll get to in a moment. It also has contact and download information, including downloads for system resources that are needed for this to use or to run. So let's take a look inside. And inside we've got very nice quick start, just a double-sided quick start leaflet, and we've actually got some software which is here on the disk, which is, I think that's stuck in, but basically talks about how to install the software and get this up and running, which is great. Let's just have a quick look first at the actual dev board itself. So here it is. So it's in this very nice foam case. We've got a series of GPIO jumpers. We've got a USB micro to standard cable. In here, I can get this out. Now this looks quite cool. This is a USB to, I would say, kind of like UART serial or something like that line. So basically, USB one side, and you've actually got a pin out, and you can see here, I'll show it out on camera, you've got the pins, and this socket here, which is keyed, so it can only go in one way, actually clips in, and that gives you direct pin out to the board. So that's really cool. I've never actually seen anything quite like that. I've seen similar things for sort of basic serial flashing for things like Arduino, but not quite as full as that. And also I kind of like that the pins are all labelled, which is really, really useful. So that's interesting. And then here we actually have the main development board itself. And this is quite a feature-rich board. Really nice, actually. So let's just move that out of the way. So we've got a colour, I think it's LCD, I'm not sure if it's OLED or LCD, I think it's LCD display. We've got some push buttons with space for a battery. I don't believe it actually needs a battery, but you can have a real-time clock battery on board. We've got an onboard speaker, potentiometer, obviously we've got various crystals to run things. Now the main processor chip is, I'm going to have a guess it's that one there. I'm not sure, but it probably is. And then we've got a main power switch here. We have a barrel for 5 volts, or we can go in via mini USB. We also have a full-size USB out, and actually quite a few connections on this. And I've also got, I believe those audio jacks or AV jacks of some description. So yeah, there's a lot going on this board. It's very, very feature rich. I'll just show the underside. Oh yeah, the underside's got a micro SD card slot as well. So this, it really is set up for all sorts of different projects. And again, it's one of these sort of development evaluation boards. So it's about learning about the Nuvoton architecture, which is an ARM-based architecture. I'll just come to that now, actually. So here in the overview, it states what it is. So it's an ARM Cortex M4, and it's the M451 series of microcontrollers. So it's a 32-bit microcontroller, and it talks about what this board actually contains. So it is a 240 by 320 color TFT screen. We have an EEPROM, SPI flash, buttons, buzzer, an audio codec, GPIO extended connectors. We've got USB host and OTG connector, SD card slot, RS485 connector, CAN controller, LIN connector. Rich application modules provide users with useful and powerful learning materials for developing and verifying the application program. Now, the Nuvoton NULB M451 requires a series of drivers, software libraries, and an integrated IDE environment called Keil uVision to work. All this is included on the CD inside the main box. The software suite and drivers are designed for x86 PC running Microsoft Windows, so I'm going to install on a Windows 7, but later versions including Windows 10 and 11 should work okay. So here is the main menu screen for the driver software, and we want to select this one here under development environment, and we need to, I think we need to install all three of these. So first of all, let's install the main drivers and the IDE environment. So we'll say yes, that's just Windows security. Okay, go install. We agree to the licensing agreement. This is just like pretty much a standard Windows installer. And this will install the main development environment. I believe the drivers for the USB are in the second installer, so we'll just let this install and we'll come straight back. Okay, so that's that done. Next we're going to install this driver, which is the New Link driver. I believe this board actually has the New Link built into it, so it's not a separate device as it is with other products. So we'll just install that driver as well. Again, standard Windows security. English, and again another installer. Yeah, we'll accept that. Yeah. We'll install. And being as it's a software driver, this will only take a few seconds. There we go, we're done. So that's that done. Now we can add the BSP software library. And this has quite a few options. So the one we need to find on the list is, I believe it's this one here. So this is on page 2, which is the M451 series BSP, and the version we got here is version 3.0.1.001. So I want to install that package. Again, this is a Chinese installer, but that looks fine. So, and this is the, I believe is the demo library software for this actual board or microcontroller. So you can see it's installing some sample code in. When I said that was in Chinese, it could well have been in either Cantonese or Taiwanese, I'm not entirely sure. But it doesn't really matter, we roughly know where the buttons are, so that's the only one that wasn't translated. Right, I think that's everything in. So there's quite a lot of other stuff on here which we could have a look at some other time, but we'll close that for now. Okay, so with all that now installed, we can open the Keil uVision 4, which is the IDE environment. It's created a desktop shortcut here on my rather messy desktop. But I said, like you're probably going to be using this on some sort of older, what I call burner laptop type machine. So this is an old Windows 7 computer, as I said already. So there we are. So this is the ARM development tool set. Okay, you probably end up with something that looks a little bit like this. So let's look at loading up a different project. So if we go to Project, and we'll go Open Project. And if you remember, we actually downloaded and installed all the sample source code. So let's just see that load up. So I'll show you where all this stuff is. So if you go back to C drive, and then it's Nuvoton, BSP library, where we've got the board series, sample code, and you've got a number of different examples here. So we want to go there, and let's have a look at SPI flash. And here's the Keil project file, and that's the project file we want to open. And here is all the components, including the compiled C code. So this IDE mainly uses C, which is the same as the Arduino IDE. So you can see it's very much the same syntax, and we're bringing in some libraries from elsewhere. So here's all the components that make up this one test library. Before we continue though, let's see if we can. Yes, we can. So before we continue, we want to clear the memory out of the board at the moment, because when we first powered it up, it had the preloaded sample example code that just made a beep, flashed some lights and showed us the screen was working. So let's clear the memory by going Flash and Erase. And you can now see the board is powered up but has gone blank, so it's now been cleared. So we can now compile this new piece of code. To do that, we can click Build, and this is going to build what's called the target files, which is the compiled data that we then need to upload to the board. Okay, and there we are. We're just about finished. We are finished. There we go, and you get a ping to say you're finished, and it's compiled the file. So this takes a few moments depending on how long or how large the program is. So once we have the image compiled, we've got a button up here which is Load. So we can click, and this will now load the compiled source code. There we go, very quick, straight into our main dev board. So nothing has happened here on the dev board straight away. So let's do a reset. There's a button just here called Reset. So we just do a reset. There you go. You can see we've now got something else has appeared on the screen. We've actually changed the program and loaded this new test program into the dev board. Just coming back to our IDE environment again, I'll just show you very quickly the debug mode, which is up here, and it has a very nice start-stop debug mode, which we'll click. This takes a few moments just to get going. It'll tell you that it's going to run in evaluation mode, And you can actually now see here, this is the main assembly, this is ARM assembly code. There we are, and you've got all the core registers, the hex value stored in the register, and you can now use the debug mode, and this is a whole separate set of tools to actually step through the program, and you can find out what's going on where. So it's not a huge program listing, and this assembly shows you kind of where things are in relation to the registers and the hexadecimal addressing. So very, very advanced stuff. This is stuff that the Arduino IDE doesn't do. Now, if you're not so keen on the Keil IDE, you can use the Nuvoton development boards with the Arduino IDE. But be aware, it does need an older and very specific version. It only works with version 1.5.8, which is quite an old build now. I have it here running on a Windows XP system. And you do need to load the drivers. Now, on the disk that does come with the hardware, there is a custom Windows installer that will install the libraries into this particular version. And what you'll get, if we look under Tools and Board, you'll see that we actually do have the NU Edge boards loaded. And the top one is the one we're using, the M451. And we do actually have some example sketches, which I can show you. So we go File, Examples, right here under NU Edu or NU Education Basic, and there's a couple here we can look at, and we could look, for example, at LED. And here is a pre-prepared sketch for the LED blinking, and you see it's written in the standard stock C of the Arduino IDE. Bearing in mind we've got the drivers, we have the libraries loaded because of that custom installer. So making sure that we have the board selected under Tools, Board, and we're on the correct port, in this case COM port 1 for Windows, we can then click to upload. This will compile the sketch like it would any other, and it will then upload to the board. And there we are. So let's just check the board, and as you can see, that demonstration program uploaded perfectly fine, and you can see there it is flashing the LEDs on a section of the board. Of course, this gives you the option and the freedom to do so much more with the standard Arduino IDE, but as I said, you do need to run this very specific version which likes to run as standalone, hence why I ran it here on an older Windows XP machine, because the drivers seemed a little bit happier on this 32-bit platform than they did on, say, a Windows 7, 10 or 11. So there we are, our review of the NULB M451 ARM 32-bit Learning and Development Board from Nuvoton, and brought to you today courtesy of TechDesign.com. All product links are in the description, so do go and check out TechDesign.com for all your component sourcing needs, plus much more. That's TechDesign.com. If you're interested in seeing more product reviews from myself here on Wi-Fi Sheep, then do check out our review and unboxing playlist. And remember to like and subscribe if you haven't done so already. And I will see you real soon right here on the channel. Until next time, bye for now.